Here's solutions to the triangle trig worksheet for Math 112. We got 5 problems here, just kind of work through them real quick. First one gives us a triangle, tells us to find the area of this triangle. A few different ways to do this. Probably the easiest is to take advantage of a little formula we have that the area of any triangle is equal to 1/2 AB sine theta, where A and B are two sides that are adjacent to this angle theta. So we could do that in this case with A and B are both equal to 10. Get 1/2 times 10 times 10 times the sine of, looks like theta in this case is 120 degrees. And the sine of a 120 degree angle, you can turn that into radians if you want. You can, I don't know, all sorts of different ways to figure it out. This is the same as the sine of a 60 degree angle. I'm stalling here to come up with the fact that that's equal to √3 over 2. Yeah? No. Yeah. Yeah. So 1/2 times 10 times 10, and then the sine of 120 is the same as the sine of 60, which is √3 over 2. So if you multiply this all out, 1/2 times 10 is 5, 1/2 times 10 is 5, 5 times 5 is 25, and you still got that √3 there, so 25 √3. Lots of other ways you could do it. You could create a right triangle by dropping a height here and figuring that we have 60 degree angles up top since this is a isosceles triangle. Yeah. So you could do it that way too, but you don't need to if you know this formula. That's the easiest way. One way or another, you should get 25 √3. I think that's enough on that one. Okay, second problem. We can actually do kind of the same trick. We can again take advantage of this formula that area is 1/2 AB sine theta. This time it's one of those sides we don't know, but we do know the area. We know that 1,000 is 1/2. Looks like A is 10 √2. B is X. And then sine of 45 degree angle. So we get 1,000 is equal to 1/2. To multiply that, I'll go ahead and multiply that. 1/2 times 10 √2 is 5 √2. Times sine of 45 is 2 √2. X. So 1,000 is √2 times √2 is just 2. So this is 5 times 2 is 10 times 2 is 20. We get 1,000 is 20x. So x is 1,000 over 20, which is the same as 100 over 2, which is the same as 50. So if I didn't screw anything up, that's the value of x here is equal to 50. Alright, now we get this crazy looking picture. Again, probably lots of different ways to figure this out, but the basic idea is we got a triangle here, we got another triangle here, then we got a circle here, and we're trying to find the length of arc BC. So we're trying to find this length right here. And we can find that length if we could figure out the radius of this circle. And we can find the radius of this circle if we can find this side right here, because this side right here will be twice the radius of this circle. And finally, we could find this side right here if we just knew this side right here. So, okay, first of all, we needed that. Just put that in black because that was meant to be in the problem. It's supposed to be a 1 right here. So we can use the fact that this is a 50 degree angle and that this is 1 to figure out this side. Maybe I'll call it X. And then if we can figure out what X is equal to, we can use another triangle to figure out this long side here, I don't know, Y or something. And then once we know that, we can get at our answer. Okay, that's enough talking. Let's do it. So we want to relate X and 1. God, this picture is horrible. This should have indicated that that was a 90 degree angle right there. So I'll go back and fix the worksheet so it says all that stuff. Anyways, if we have a 90-degree angle, we can kind of take advantage of SOHCAHTOA. We want to relate the side opposite 50 degrees with the hypotenuse. So it's sine that relates those. The sine of a 50-degree angle has got to be opposite over hypotenuse, x over 1. In other words, x is equal to sine of 50. So this right here is sine of 50. And now we want to relate, it looks like, what is this, the adjacent and the opposite. So the tangent of a 20-degree angle, tangent is opposite over adjacent. Opposite we just said was sine of 50. And adjacent would be, I don't know, maybe we call it y, this length here. Hard to draw straight lines, but good enough. So tangent of 20 is opposite over adjacent. And we got that. We got sine of 50 over y. So what that tells us is that y is equal to sine of 50 over tangent of 20. So what that tells us is that the radius of this circle, maybe I'll call it r, is equal to half of that value, sine of 50 over tangent of 20 over 2 tangent of 20, I guess is one way to write it. And now that you know the radius, we can come up with the arc length. Arc length is just equal to the radius times the radians. So in other words, this angle here measured in radians. So we can convert, maybe I'll say 20 degrees. In radians, we can multiply this by pi divided by 180. And let's see, that's 2 over 18, which is 1/9. It's pi over 9. So this 20-degree angle right here in radians is pi over 9. So arc length is equal to sine of 50 over 2 tangent of 20 times pi over 9. You could plug that mess into a calculator if you were the calculating type. I think I'd rather just leave it as maybe pi sine of 50 divided by 18 tangent of 20. And call it good. Say that that's this measure right here. All right. Number 4. Find the area of the shaded region in the circle centered at A above. All right. Let's see. I guess a few ways to get at this. First of all, we're going to want to know the area of this triangle, and then subtract. If we could subtract that from the area of this entire wedge, we'd be left with just this shaded area. So let's see the wedge. We can get at that by noting that the area of the entire circle is pi r squared. But we don't want the entire circle. We just want 135 180ths of it. You could also convert this into radians, and it's the number of radians divided by 2 pi, and then those pi's cancel out. I should do it that way. That's the way I think I taught you guys to do it in class. So let's do it this 135 degrees. If we want that in radians, we can multiply that by pi over 180 degrees. And let's see, 135 divided by 180 is 3/4, perhaps? I think that's right, because 45 goes into this thing 3 times, and 45 goes into this thing 4 times. So I think that's 3 pi over 4. So the area of the wedge is pi r squared times radians over 2 pi. But what you'll notice is then those pi's cancel out, and so maybe a simpler formula is it's just r squared radians over 2. And r squared is 100. Radians is 3 pi over 4. And we want to divide that by 2. So this is 50 times 3 pi over, well, that is equal to 150 pi over 4. If you simplify this a little bit, this is 50, and 50 times 3 is 150. And that's 75 halves, or 37 and a half. Something like that. So the entire wedge is 37.5 pi. But we don't want to know the area of the entire wedge. We want the entire edge minus this triangle. Good news is that triangle isn't too hard to find. We can revert back to the fact that it's 1/2 AB sine theta. And that formula works out nicely in this case because A and B are both 10. You can think about this as B over here, and they're both a radius of this circle. So 1/2 times 10 times 10 times the sine of a 135-degree angle. Let's see, sine of 135 is the same as sine of 45, which is 2 root 2. So this is 5 times 10 times 2 root 2. In other words, this is 100 root 2. So what we get is that the area is the area of the wedge, 37.5 pi, or I think I told you to leave things as fractions, so 75 pi over 2 if you don't want to. Sure, 75 pi divided by 2 minus 100 square root of 2. So whatever this number is, you can throw it into a calculator if you're the calculating type, and that's the answer of this shaded area. All right, last one. How am I doing on time here? 12 minutes. Wow. Sorry for the long video. Find the area of the shaded region in the circle centered at A above if the arc length BC is 10. Okay, so if we could figure out, is that enough information? I think we need to know a radius too. Hang on. This was supposed to be 12 here is my radius. And if you have that information, then I think we can do it all. I guess the first thing would be to kind of figure out what this angle here is. Maybe I'll draw it in and label it theta. And we can figure out the angle theta using our formula for arc length. We know that arc length is equal to r times radians, the radius times the radians of the angle. And in this case, the arc length is 10 pi, labeled in the picture. The radius is 12, also in the picture. Maybe instead of radians, I'll say theta here. So we can figure out that theta is equal to 10 divided by 12, or 5 pi over 6. And once you know that theta is 5 pi over 6, we can find the area of this triangle by saying that the area is 1/2 AB sine theta. And again, the good news is both A and B in this picture are 12 because they're both equal to the radius. So 1/2, 12, 12 sine of 5 pi over 6. Which is, well, let's multiply that out. 1/2 times 12 is 6 times 12. Sine of 5 pi over 6 is the same as sine of pi over 6, which is 1/2. In other words, we get a nice round number. We get 36 is the area of this triangle right here. And that finally is the end of this worksheet, or the end of, this worksheet in this video.